So in the topic of matrices, we are going to see about how a matrix is been formed. A matrix can be either shown by a square bracket or a normal bracket consisting of rows and columns. Here is a situation given to you, that is, a shop is selling three different types of fans: stand, ceiling and wall. And the process can be done in two ways. One is in-store selling, second is online selling. So in-store selling, you have 16 stand fans, 18 ceiling and 11 wall fans are being sold. So this becomes your first row: 16, 18 and 11. Online fans of the given categories are shown as 5, 10 and 4, and they are shown over here also 5, 10 and 4. So a matrix can be formed from a given situation having rows and columns. You can have 2 by 2 matrix, you can have 3 by 3 matrix and so forth. A matrix with m rows and n columns is called as m by n matrix, in the order of m by n. Here in this particular case, you have two rows and three columns are there. So these are called as the rows and this is the columns. Next is, what exactly is an equal matrix? When there are two matrices M and N, both are equal, that is each element, corresponding elements are equal, then we say such a matrix is an equal matrix. So for qualifying any matrix to be equal, the order of both the matrix should be same. So here the order of the matrix of P is number of rows are 3 and number of columns are 2. So it is a 3 by 2 matrix. Similarly, for the matrix Q, the number of rows are 3 and number of columns are 2 is again 3 by 2 matrix. So when the order is same, then we can make the matrix to be equal. See over here, 6 and x both should be equal. So if you try to see 6 and this x, both are equal. So x will become equal to 6. Secondly, 2z minus 3 should be equal to negative 2. 2z minus 3 should be equal to negative 2. And if you equate it, you get 2z minus 3 is equal to negative 2. Further to that, y is equal to 3. So the answers will be x will be equal to 6, z will be equal to 1 by 2, and directly y will be equal to 3. How do we add and subtract matrix? Add and subtraction of matrix should we again have the same order. So each element will be subtracted from the other element. For example, here you have P and Q matrix. We want to find out the value of P plus Q. We want to add P with Q. So 6 will be added with 2, 0 will be added with 3 and so forth. So 6 plus 2 becomes 8, 0 plus 3 becomes 3, 3 plus 3 becomes 6, 2 plus 2 becomes 4, negative 3 plus negative 2 will become negative 5 and negative 5 plus negative 5 will become negative 10. Let us now try to see what exactly is a scalar multiplication of matrix. If the matrix A is given as A, B, C, D as the elements, and you want to multiply the matrix A with a scalar multiple n, then you have to multiply each and every element by n. Therefore, NA becomes equal to n small a, nb, nc, and nd. Let us take an example over here. If P is given matrix and Q is this given matrix, we want to find out 3 times P minus Q. So first work is to find P minus Q. So we find P minus Q. 7 minus 2 should be equal to 5. 9 minus of minus 3 should be equal to 12. Negative 3 minus 1 should be equal to negative 4. 8 minus 5 should be equal to 3. 6 minus 0 should be equal to 6. 12 minus 4 should be equal to 8. So you first find out the subtraction of the corresponding element. We want 3 times P minus Q. So multiply this matrix with 3 each and every element. 5 times 3 is 15, 12 times 3 is 36, 4 times 3 is negative 12, 3 times 3 is 9, 6 times 3 is 18, 8 times 3 is 24. So that is how we get 3P minus Q. Now here in this case, very important part we are going to see is the multiplication of matrix. But before going to actually try to do a multiplication, when is the multiplication of two matrix can be performed? The matrix A is the order of m by n and matrix B should be order of n by p. If you see over here, the first matrix number of columns should be equal to number of row of the second matrix. A is multiplied with B. The number of columns of A should be equal to number of rows for B. Then and only then you can multiply. Further to that, A times B is not equal to B times A. So we cannot say that multiplication is commutative. A times B may or may not be equal to B times A. The resultant matrix which you get will be order of M by P. So the resultant matrix A times B will have M rows and P columns. Let us now do one example based on to this particular part. Here we are given two matrix, matrix A and matrix B. For simplicity, we are taken only 2 by 2 matrix. Matrix A has the elements 2, 3, 1, 5. Matrix B has elements 6, minus 7, negative 2 and 1. When you multiply A times B, you get this result. But directly understanding this is a little bit complicated. So what we do is we block each and every element now. So just block it out. We are blocking each and every element. How do you multiply? First row of A is multiplied by the corresponding elements of the first column of B. Here it is first row is 2 and 3 and first column is 6 and negative 2. 2 times 6 is 12 and 3 times 2 is negative 6. That's what you get here. 2 times 6 and 6 3 times negative 2. First row and first column will be first row, first column of the resultant matrix. Next is first row and second column. So first row and second column, if you try to do it, 2 times negative 7 and 3 times 1, you will get this particular element. 2 times negative 7 and 3 times 1. Add both the parts. Now we go to the second row and first column. When you do it, 1 times 6 and 5 times negative 2. 1 times 6 and 5 times negative 2. You add it up. Further to that, second row and second column. 1 times negative 7 and 5 times 1. 1 times negative 7 and 5 times 1 will be second row and second column. That answer comes out to be equal to, if you do this particular calculations, 6 times 2, 12, 12 minus 6 will be 6 and so forth. So you do this calculation, you get the final result over here.